Well, good morning. My name's Amanda Rice from Boeing, and the good news is we're running slightly ahead of schedule, Kennel tells me. The bad news is he told me I could take all the time I needed to catch us up. No, I don't want to do that. I think I'll also keep us on track and keep us slightly ahead of schedule. The topic here is to familiarize you with the Payload software integration process. Next slide, please. I'm going to present a range of software architectures that you might choose to implement to conduct your research at a very generic nature, and for each of those architectures, make you aware of things that the integration process will need from you, will require from you. And of course, the type of software architecture you implement to conduct your research is largely dependent on the type of research you want to perform, and it's also very highly dependent on the operations concept you want to put in place for conducting that research. You can do anything from implementing software which runs on a laptop that's operated by the crew, or you can have your software embedded with your hardware on a controller and it's operated from the ground, and you can do variations of those architectures across both those extremes. Next chart, please. I didn't have any graphics either, so I had to come up with something to grab your attention before we get into all the text. So what we have here is 4 doors representing kind of a range of the software architectures that you can implement. And we're going to start with the red door and work our way towards the green door. So we'll start with a very autonomous system first and work our way. Next chart. So if we look at a highly autonomous payload software architecture, a brief description that's on the left. This would be an architecture where your payload software may self-initiate when your hardware is integrated and activated on board. Your software is collecting whatever data is required of your research and storing it locally, and that data comes back to you when your hardware and your files are returned back to the ground. Highly autonomous, and you're thinking, okay, I really don't have any software interfaces with the program. Well, if you look over on the right side, the key features about this architecture, although it does sound completely independent, you may still need to have a software interface. And you'll hear a term a bunch called health and status data. Typically, any powered hardware that we integrate is required to provide health and status data, which can be downlinked to the real-time control center for the ground operators to monitor and to know that your hardware is operating safely and as they expect it to operate. So if you are required to provide the health and status data, it typically includes things like current or voltage to your hardware, any sort of temperature measurements or fan speeds, information about the physical components within your hardware to make sure it's operating within nominal ranges. If your payload is hosted in a facility, typically you can provide that information to your host facility and they'll bundle it up and get it in the downlink paths to reach the real-time folks looking at that data. But in order for all that to happen, you need to define what your health and status parameters are, and the program has developed a database called the Payload Data Library, where you can go and define those parameters to the program. And your PIM can direct you how to get into PDL and set up those accounts for you if it's needed. PDL is used to build 2 very important products that make everything happen. The first is the command and data handling set, which is given over to the Huntsville Operations Support Center, and they develop telemetry and command databases in their architecture so that when you issue commands, they know about it, they can route it forward, and they can get your health and status data back from on board, process it, and make it available for monitoring to the real-time operators. Also, other additional files are built on board for the onboard avionics payload MDM, payload multiplexer, demultiplexer, that handles the routing of that health and status data. Okay? So health and status data, that's the first thing you need to learn. If we move to the next slide, now we're looking at a payload software architecture, and I call it a semi-autonomous type of payload. If you look at the description on the left, your software resides on your payload processor, and there's an interactive capability from the ground. Send commands to that payload, get information back from that payload. So if we look over on the right, the key integration information for that architecture, again, the health and status data interface will likely still apply to you. And then you've got to think about other things. How do the systems know how to route my commands and my telemetry from my location? So you'll also make use of the payload data library to enter information about the commands you expect to send to your payload, and to give some overview information that you do have telemetry you wanted routed back to your operations location, overview information about the packet sizes of your telemetry information. So you'll put that into PDL. Also, if you plan to have this interaction with your payload from a remote ground operations location, you're going to do some coordination with the ground systems requirements team. That'll happen fairly early on during your integration phase. They will work with you to coordinate requirements for your remote location, to establish a data feed to your location, to set up accounts for people who are going to be issuing commands and working with the HOSC to get the data going. And also, you'll need to think about the ground software that you put in place to interact with your payload on board space station. Yesterday, I briefly mentioned the Telescience Resource Kit software that NASA has developed and makes available to payload developers. It's a great way to interact with your tool. A lot of the software interfaces are pre-built for you. And let me also note, I have a lot of links at the end of this presentation to the resource materials you can link to. Okay, if we move on to page 6, our next architecture I call Flight Interactive Payload Software. If we look at the description on the left, this is software that the crew will interact with. It might be a portion of the hardware and a software display integrated with your payload hardware. It might be software that runs on a laptop associated with the host facility you're integrated in, or a standard use laptop that can be made available for you. Okay, so the things we need to think about if we have this type of architecture are on the right. Okay, so we start thinking about displays and procedures. For crew interaction, you're obviously going to have procedures for the crew to look at your displays and know how to respond to it. Any displays that you develop, if we look down a couple of sub-bullets there, your payload displays must be designed to be compliant with the integrated displays and graphics standards. And I have a link provided to that information to you. Additionally, there's a payload display review team that it would be great to get with them early on in your software design. They can work with you, review your designs, and guide you regarding things you need to change so that you will end up ultimately being compliant with IDAGs and being certified to be flight ready. Okay, so get with the PDRT early if you're going to have this type of architecture. I mentioned the use of onboard laptops and compatibility. There's a website link that you can link to that gives you specifications regarding the onboard laptops that can be made available to you. The responsibility for developing your software always, of course, resides with you. So you want to be aware of the operating systems, the specifications of the laptops that you will be operating on so that everything's compatible. You're responsible for testing your laptop on a ground version that's compatible with the flight versions to make sure everything works properly. And also, if your laptop is going to operate on a host facility, The integration team will test your software on the host facility computer to make sure it's compatible with other software applications that might be operating. Okay, additionally, if you're going to fly laptop software or need to launch a software media to update your flight load, the program can develop that flight media for you. You have the responsibility of turning over your final media load to the program, and the program will produce the flight media on flight qualified media and get that all coordinated for you to be manifested and launched to orbit. Okay, moving on to page 7. Our final architecture I call a software-only investigation, and this is research that is conducted purely with software. No unique payload hardware exists. Your software may be loaded on an existing computer and operate autonomously, semi-autonomously, or with crew interaction. So it can be software only, but you can do it from the ground, or the crew can interact with it to collect your data. Typically, no health and status data is required on laptop data, so you don't have to worry about that. The real-time operators have other methods of watching to make sure a laptop's operating nominally. Also want to make you aware that some of the host facility laptops provide partitions to you where you can save some of your data files that you're collecting from your research in partitions that are established for you. And there are ways of getting that information downlinked and returned back to you. And depending on the level of interaction desired with your software on board, everything we've talked about previously can apply to this software architecture as well. If you're going to be sending data down, of course, you need to put that information into the payload data library, as we discussed. If your software architecture, you'll be interacting with it from a ground location, you'll need to coordinate that with the ground systems requirements team. Be sure to look at the Trek software, see if that can be helpful for the implementation of your software command and data acquisition. Again, software only could be totally up to the crew to operate it. Again, you would want to get with the payload displays review team, have them work with you, review your design, make sure you end up being IDAGS compliant. And again, you want to be familiar with the specifications of the laptops available to you so that your application's compatible, and then your media can be launched. Okay, page 8. This is a lot of information, a lot of variables. This is very high-level information. Rest assured that your PIM is knowledgeable of all of this and will coordinate with you. And depending on the type of software architecture that you do choose to put in place, coordination with the PDRT or getting your data into PDL to develop the data sets, that'll all be placed on your integration schedule. Next slide. And this is the final chart, which references many of the key items I discussed in the overview and provides you a link to the information. I believe you're going to have a password into the POIC system to get to the Trek material. But if you need information about Trek, contact us and we can get Michelle Schneider certainly to get you information where you don't need to get that password established at this point. Okay, very high level. Do we have questions? Okay. Well, great then. Let's move on.